So this is the approach 4. It is called the Dutch National Flag algorithm. So this is the most optimal solution to sorting the colors. There's nothing more. There's no more optimal solution than this. And interviewers expect that you tell this algorithm for this specific problem. Okay, so what is algorithm or algorithm and how it works? So the algorithm has three main things. So it maintains three pointers, namely high, mid, and low. Okay, let me explain what. So let's take the array. So this array. This array 202. Oh my, 110. 110. Okay. So this is our array. This is our vector array. So now what is done? We use these three pointers, which are high, mid, and low. So we initialize low and mid to the first element and high pointer to the last element, the vector array. Now, so the initialization is, I'll write it down here. Last element, first L, and same. Okay. So now, so uh, okay. So what happens is, uh, if there's a we use a while loop which checks where if mid pointer is lower than high pointer, and if only this is the case, does it go inside the while loop. So now inside the while loop we have three conditions. So if first condition, if the element, okay, so if the element in this question, it's called nums. So nums, if nums equal of nums of mid, the pointer mid, the element pointed by the mid pointer is 0, then we are going to swap. We are going to swap the low pointer with the mid pointer and mid plus plus and low plus plus. Okay, so this is the condition if nums of mid is 0. If nums of mid, so else if nums, okay, else nums of mid is equal to 1. Nums of mid is equal to 1. What we're gonna do is, okay, so if nums is equal to 1, we're just going to do mid plus 1. So a mid plus plus. So mid plus. And else if nums of mid is equal to 2, then we are going to do high minus minus. Okay. So how does this work? Okay, let's check it with iterations. So when these are iterations. Let's see, iterations 1. Okay, so the iterations are so in iteration 1, what happens is, so when it goes to the for loop, so in while loop it checks first is mid lower than high. Is mid lower than high? Yes, it is true. That's therefore it swaps the element which is at position which is pointed by low. No, okay, wait. Yeah, so it checks this while loop condition. This while loop it checks. Is it being satisfied? It is being satisfied because a high value is nums size minus 1, the end element, and the mid is pointing to starting, so it's satisfied. So now it goes inside. It goes inside the while loop. Inside the while loop, then it checks the what element is mid pointing to. So mid is pointing to 2 here. So now what happens is in yeah, so it's pointing to 2. So it's if it's pointing to 2, oh yeah, there is nothing here. It swaps mid and high here. Okay, so if iteration yeah, the first iteration, so it's equal to 2. So now what happens is this mid pointer is swapped with the high pointer. So so this so now these two are exchanged. So now it's 2 here and 0 here because the pointed by the mid is exchanged, and mid and high is so mid is still pointing to this, but high has come down 1. High is pointing here now. Okay, so now again it checks the while loop condition. Again we can see that it's satisfied. Its mid is 0 and high is second last element. So wait, let's give iteration. I'll yeah. So 0 1, yeah. So high yeah. So this is fourth element, fifth element. High is fifth element. Mid is 0. High is 5. Okay. So now in iteration 2. In iteration 2, what happens is it goes into this, it checks this. Now it sees that mid element is 0. So when it's 0, what the program does it is swaps this 0. It swaps the 0 with, so what program, it swaps the 0 with the position pointed by the low pointer. So now 0 is swapped and the resulting will be the same because the same element is swapped. But both the the high, low and medium, both of these pointers are okay, so 0. Yeah, both of these pointers are now here. So mid has increased by 1, even low has increased by 1. Okay. Okay. Now it checks is the now again the loop runs and the while loop is satisfied. Again it is 0. So again uh, these two are at okay. So this is iteration 3. In iteration 2 this happens. In iteration 3 again, as you can see, nums of mid is 0, and that's why it's exchanged, and mid and low pointer are updated by 1. Okay, so now both come here. Now as you can see, mid and low. And now as you can see 2 is there. We are talking about iteration 4 now. In iteration 4, you can see that 2 has come, and still low is yeah, so 2 has come. So now 2 will be exchanged. As you can see, if nums of mid is 2, then we have to swap mid and high. So mid and high get swapped. So okay, mid and high are swapped, and then high is reduced by 1. The high pointer is reduced by 1. This point, so it points here. Okay, so high points here. Now, now the fourth iteration is on. Now fifth iteration. In the fifth iteration, mid value. Okay. Now in the fifth iteration, as you can see, mid is 1. So when mid is 1, it simply increments the I pointer. Sorry, the mid pointer by 1. And now mid pointer is here. This is greater than equal to. So yeah, so it's pointing to the same location where high is pointing. But now still the condition is satisfied because mid is equal to high. So now what happens is again it runs, and as you can see that uh, the mid is pointing to 1 again. That's why as mid is pointing to 1, mid is incremented by 1 again. It is incremented by 1 again, and it points here. At this point of time, as you can see, this condition is not satisfied. So it exits out of the while loop, and we thus get the answer. Okay, now let's code it. Okay, so we're gonna declare mid equal to 0, high equal to 1, and low equal to this is nums dot size minus 1. So it's pointing to the last element. That's why high is nums dot size, the size of the vector array minus 1. So now we'll run a while loop, which is our like base condition. If it fails, then the whole thing is stopped, execution is stopped. Okay, so high should be greater than or equal to mid. Simple. Okay, so now we have the if condition. So if nums of mid, so we are always considering mid. So this is kind of like the 2-point approach. So equal to 0. Now when nums of mid is equal to 0, we are supposed to submit is 0. We are supposed to increase mid and low by one. First, yeah, and we need to first actually, yeah, I didn't say the correct. First, you need to swap them. First, you need to swap the elements pointed by mid and element pointed by low. So low basically collects all the zeros and high collects all the twos, and mid is just a pointer which moves along the array and puts everyone in the correct place. Okay, now if nums of mid is equal to 1. So now as I said that low collects all the zeros, and high collects all the twos. Mid is just trading to the array. So if it encounters a one, it just need one just needs to be in the middle. So nothing happens when one is encountered. Only mid plus plus. So if mid equal to 2, so if mid is 2, then you have to swap nums of mid and nums of the elements pointed by mid and high. You gotta swap them, and you just gotta do high minus plus. Oh, silly mistake. Okay, so it's working now. Let's submit and see. Yeah, so it's accepted. So this is the famous Dutch national flag algorithm problem. This is asked a lot in interviews, and this is the optimal solution for it. Hope you have understood.